Hi guys. Today we are gonna solve 2018 IMAT past exam. The physics mathematics section. We start with physics, move on to mathematics. Let's go. Question 55.
An electric train is traveling on a straight horizontal track. A constant resultant force greater than zero acts on the train in the direction of the train's motion. What happens to the magnitude of the acceleration and to the magnitude of the velocity of the train while this force is acting?
So if there is a force moving the train, so there will be acceleration.
Yeah, of course.
It's like straightforward, like, no, I don't see any, so let's look for the answer, like, without reading everything. Remains constant. Yeah, the acceleration is constant. This is true. Acceleration itself is constant, yeah?
Yeah.
And the velocity will, of course, go up, yeah?
Yeah. So it's gonna be B.
The acceleration remains constant, also good, and velocity increase. This is not good. It's B. Let me check. This is question number 55B. Okay. This is an easy question. Let's go. Let's check out the 57. Read it, please.
Yeah. 3 spherical particles have the following diameters. 1,650. Is that picometer? Yeah. 1.5 nanometer and
micro.
0. Micrometer. Yeah. What is the order of the diameter?
Okay, this is like a game with the units, yeah?
So yeah, just the units.
So let's check it out. We have a meter. We have a kilometer, yeah? I think we have a millimeter and a micro, I guess, yeah?
And then nano.
Nano, and after pico, yeah?
Yeah, pico is 10 to the power of minus 9.
Of course, we have a centimeter, but it breaks the, constancy, because this is everything here is 1,000 times more.
Yes.
Of the one, in the list. The centimeter is different. Did you ask me something?
The nanometer is to the power of minus 6 or 9?
So it depends, like if you take here, like this is 1, the meter, depends what you want, yeah? So this is like minus 3, minus 6, minus 9, minus... each time you add the 3, yeah?
3, yeah.
So, yeah, it depends which one, and this is like plus 3. So depends which, relatively to what you want to work with. So because we have here like just 3, yeah? So we don't need to take relevance to the meter. So actually we take relevance to we have like this 3 working here. So this is 1, this is 10 minus 3, this is 10 minus 6. Okay?
Yeah.
So, micro, 0.0036 micrometer. Actually, this is, like if you convert it to nanometer, it's better because you will have like a 3.6 nanometer, yeah? Yeah, and if you wanted in picometer, you can also multiply it by 1,000. This is 3,600 picometer. Okay.
Yeah.
So how to make it as fast as possible. I think make everything nano, because you see the pico is 1000 here, yeah. So let's make everything nano. So fast solution 0036 micrometer. This is 3.6 nanometer, 1.5 nanometer, and 1650 picometer, which is 1.56 nanometer. And now you can make like a list, yeah. So if this is A, B, C, this is A, B, C. The biggest one is A. Sorry, the biggest one is actually C, yeah. C. No.
No, A.
No, I made a mistake here. Yeah. I made a mistake by organizing them. Okay, so I will repeat like one step back. Again, A, 1650 picometer. It's 1.65 micro. B, it is already nano. Sorry, this is nano. C, 0.0036. What is it? Micro. It will be 3.6 nanometer. So biggest is C, after it is A, after B, and now you can choose like which is the list is correct.
D.
I guess it is D. Yeah, this is A. Sorry, C. Yeah. A, B. In the order smallest first. You see?
Smallest first.
It's very confusing. Yeah, very confusing. So I guess it's E. Yeah, B, A, C. That's okay. Yeah, I think E. Let's check. 57E. Correct. Okay. This is also an easy question. Let's continue to 58. So to who is watching this video, our student Razan have a theory that it's more efficient to start with the physics, and after going to math. By your experience, it's like physics somehow you can say like heats up the flow the energy of thinking, and solving after the math, it will be less stagnation. So it's like flowing better to start with physics. Okay, we are doing this actually, and it's also efficient. I don't know if it's like a real thing or no, but it's working for us. Okay.
Yeah, it's okay.
Next question. 58.
Okay. A wire made of metal of uniform resistivity, 1 multiplied by 10 to the power of -6 ohm. Oh, this is ohm,
yeah.
Ohm meter is 2 meter long and has a diameter of 2 multiplied by 10 to the power of -3 meters. What is the electrical resistance of this length of the wire?
Yeah, this is like calculating or the resistance from the shape. From the shape. A lot of things in the shape decides how much resistance there is for electrical current. So resistivity is like somehow of property for this metal. That's like some special parameter for this metal. It is like ohm per meter. So how much density it's of resistance. A length, you have like the length, diameter, and you have the radius, which is like half of it. A cross section, you can
a cross sectional area.
So what is a resistance? So it's the resistance in this case will be rho L on A, and rho is actually here the resistivity.
Yeah. Rho multiplied by L divided by A.
I think it's 110 minus 6 ohm for per not multiplied by meter. Okay, L is the length. Okay, length. I think it's 2 meter. We have the diameter.
Yeah.
We will call it D. This is 2. So from the diameter we will calculate the radius, which is half R1. So what is A? A, we can calculate here A. It is a cross-section area. I will write cross-section area. So it's pi r square. If this is like r, let's make it small r. Yeah, so it would be pi 10 minus 6, because r square is minus 3 square, and you multiply them, yeah?
Yeah.
And this is meter square. Okay, this is like, I will just, so this is A. We can now, we have all what we need to for this formula. So we have, I will take it a little bit to the left, so like solve everything in this, in one one
page.
One page, yeah. One whiteboard, one page. So rho LA. So the rho is 1, 10 minus 6. L is 2. A is how much? Minus pi.
Yeah.
So we have like 2 pi. And what about the units? This is ohm meter multiplied by meter divided by meter square. So this is ohm, and this is the resistance. The resistance, not resistivity. This is resistivity. This is okay. So this is resistivity, and this is the resistance. Okay. Okay, so I guess the answer is how much? E?
E, yeah.
Yeah, let me check. E. Next. Question 59.
Yeah.
Before we continue, let's maybe try to figure out what's happening here. So this is pi r square, this is L, and the rho is like somehow here, yeah? So what we did is we multiplied by L divided by this A, the section here, because as bigger the section, okay, for to understand, because resistivity, it's like more deep micro in the materials,
Yeah.
It's about bonds, about actually the structure of the atoms, etc. So to imagine this, what's going on there in this level, like let's imagine not exactly in the atom level, but like a tube of water, for example, or something like this. It's more easy. So as bigger the tube is, as easier the flow of water, less resistance. So the section, the cross section of the area is down. So it's become bigger, it's more easy. The resistance go down. We are calculating the resistance. Now, because of, so the rho is, if it's bigger, it means there is more resistivity, there is more, let's say, like some metal balls inside that prevent the water to go, yeah, or some anti-electrons to make them flow, yeah, catch electrons, or attract electrons, or materials that have some
or maybe non-polar
positive
bonds.
yeah, exactly,
but we're not gonna get into because water is polar.
Yeah. So because of this material, like I imagine it as density, as density, if you speak about flowing of water.
Yes.
So as longer the tube, you will have more more from this material. So as longer the tube, as longer you have more resistivity and more resistivity. So the resistance will be bigger. So that's why this formula looks like this. So just to okay. So next question.
Yeah. Okay.
1 second. One second.
Should I read?
Yeah.
Okay. The Earth's atmosphere contains oxygen and nitrogen. The mass of an oxygen molecule is greater than the mass of a nitrogen molecule. The temperature of air in a room on a particular day is 300 Kelvin. Below are 4 statements about the motion of the 2 types of molecule in this room. Which of the statements are correct?
Statements about the motion of
so it's kinetic energy.
Okay. Okay, let's read the statements.
I think the smaller the molecule, the more it's gonna diffuse.
Okay, so what equations we know here? You remember?
The Boltzmann and the kinetic energy.
So yeah, we have like 3/2 of kT. Ek is kinetic energy. K here is Boltzmann. Constant. T is temperature, absolute temperature. In Kelvin, which is absolute, yeah?
Yeah.
This is absolute. Okay. Kelvin, exactly. Okay, we have also that the speed, yeah, is related oppositely with the mass. So what we have here? We have like two particles.
Molecules. Yeah.
We have oxygen and nitrogen. Who's bigger? The oxygen, yeah?
Yeah.
The temperature is 300. Okay, so if the oxygen mass is bigger, it means the nitrogen will be more fast. Correct?
Yes.
Okay.
Yeah. More volatile. Yeah.
Yeah. Okay. So let's see the statements.
They have an equal mean square velocity. No, I don't think so.
You read it? They have an equal mean square velocity. No, of course, because this depends on the mass. They don't have an equal mass. So for them to have a by the way, this is I forgot to make here mean. This is like the mean. V square this is the mean, the average of velocity. Because sometimes, so look, if this is like M1, this is M oxygen and this is M nitrogen, okay? This is like bigger, yeah? So you will have like something like this. This is oxygen And you will have here something like, sorry. So this is oxygen, and this is nitrogen. So the speed can go, sorry. Yeah. 1 second. So the speed here will be of oxygen something like this, and here the speed will be all the time higher. Yeah. So the average here is higher than the average here, but the speed itself of oxygen, yeah, can be sometimes lower even than the speed of nitrogen, yeah, because it can hit another molecule,
atom
and molecule, body, yeah, and slows down to zero also, but the mean. So they, so it's important to understand that this is speaking about the mean. Anyway, they have the equal mean, no, because different masses. Yeah, continue. 2.
A nitrogen molecule has a greater mean square velocity than an oxygen molecule.
Okay, this is okay. Next.
A nitrogen molecule has a greater mean kinetic energy than the oxygen molecule.
So because of T is equal, yeah?
Yeah.
So they have the same kinetic energy. So why they have the same kinetic energy? So why they have the same kinetic energy? Because kinetic energy is also half mv square. Yeah? So they have the same kinetic energy, but because the mass is bigger, the v is smaller. And if the mass is smaller, the v is bigger. So yeah, they have the same kinetic energy. Who is more, who have less weight, move faster, but both of them have the same energy. So what we have here, a nitrogen molecule had a greater mean kinetic energy. This is not true. Kinetic energy is
same
not
thing
true.
here.
Yeah. So they have the same kinetic energy. Okay, what is the answer?
D.
Statement 2 only. Let's check it if it's true. Question number 59. D is correct. So we move now to the math. We finished the physics. We go to the
That's
math.
it. Number 60 is math.
Yeah.
Okay.
Let's go. So we start by question number 53, actually, the first one in this section.
Okay. The equation below has 2 roots. What is the sum of the 2 roots?
Yeah, okay. We did yesterday something similar.
Yeah.
So like the standard is to just like solve it normally, yeah, which is, you know, x plus 4 equals x plus 1, which is x squared plus x minus 4, which it will be. Yeah, I think it's like very easy. So you have 2 and minus 2, yeah?
Yeah.
So it's like
0.
Yeah. So let's see, this question is 53E. Yeah, it's correct. Yeah, this is an easy question.
Yeah.
So this exam, I think, maybe they made, you know, the hard questions not in math and physics, maybe in biology.
In biology, yeah.
A pentagon.
Yeah, we spoke too fast, I think. A pentagon has one line of symmetry. all 5 sides are 6 centimeters, and the interior angles in anti-clockwise order are 60, 150, 90, 90, and 150. What is the area of this pentagon?
Okay, let's do it. So,
Okay.
pentagon, 5 sides. 1, 2, 3, 4, 5. So all of them are 6, 6, 6, 6. But the angles anti-clockwise in order are 60, 150, 90, 90, 150. Actually, it doesn't look like this. So if you have 90, this is 90. Yeah.
Right angles.
Let's try to, draw it. But what is like 150? I don't get it.
How are we gonna draw this?
Like what is 100? Maybe it's like from outside. 190, 90. Okay, so we have here. This is 90, and this is 90. So beyond the 90, you have extra 150, another 60 here, another 60 here. Like total is 150, and they meet up here with a 60. So you have like a square, a triangle, 60, 60, 60, a square. Not a square. Yeah, actually it's a square, because this is 6, 6, 6. It's a square, and this is a triangle 6, 6. It should be here also 6. Okay. So what we want? What we need? Area. So 6 square plus 6 square divided by 2. No? I made
But they need it in the
no,
sorry, root in the answer.
Not 6 square. Sorry. You have the oops. You need the height. This one.
Yeah.
So let's calculate this, and it will solve very fast. So this one is 3. So you have 3, 6. What is Pythagoras for 3, 6? We don't have, yeah? 3 square x square equals 6 square. How much is 36 minus 9? 27.
Yeah.
Yeah, so you have x square root of 27. Okay? So you have 6, 27 by 2. Let's make it more simple, yeah? What is 27? 27 is
9 multiplied by 3.
3, 3, 3, right?
Yeah.
3, 9, 3. We have here 3. You see in the answer, yeah?
Yeah.
So we can take out a 3 like 2 times. So you have 6 square plus 6 multiplied by 3 square 3. 6, 2. This is 3 here. So you have 6 square plus 3, 3, 3, which is how to do this? What do you want? How to make it? So we have here 9. So 6 square plus 9. What we have outside here? Some 3 or some 9, yeah? So this is like 36. So I think we'll take out a 9 outside. So 9. And what is this? 4.
Yeah.
So it's like this one, yeah?
Yeah.
Okay.
Let's check.
Check. 54 E. Okay, something to understand here. I think nothing. I think it's
I think it's okay.
Yeah, everything is okay. Maybe some trick to divide.
Just the simplifying. That's it.
Dividing it to half. Okay, next question, 56.
Okay. Which of the following is an equation of the line that passes through 4, 3 and is perpendicular to the line y equals 2x plus 4?
Perpendicular, the multiplication of two perpendicular lines, they have the slope of a perpendicular line to this line should have what? Forgot to make it full view. Should have minus half, yeah, because 2 multiplied by b minus 1, so b is minus half. It should have the opposite and the invert slope, okay?
Yeah.
So you have y equals minus half x plus, I don't know, t, yeah? It passes through 4.3, so you have like 3 equals minus half of 4 plus t, and this is minus 2, yeah? It's like 5, I guess, yeah?
Yeah.
5, yeah, so y equals 5 minus x2. Which one is it? Need to like find out now. It's like the shape is different. Okay, what we have here, the 5 is outside and the y is with the x, so we have y plus x2 equals 5. Should be something like this. You can multiply by 2, so you have 2y plus x equals 10.
So we have that.
Yeah,
E.
yeah, this is okay. Let me check. 56e. Okay, also standard. Let's continue. We have here question.
Okay. We need to
Yeah.
evaluate.
Let's go.
Mm.
So, what is it? 5.4? From where is the 5.4? Okay, so what we have here? Let's try to make something
Okay,
out
let's-
of this, yeah?
Yeah.
3, 3, 10, 9, yeah, correct?
Mm-hmm. Mm-hmm.
2, 10, minus 5. Okay. 9 minus 5. How much is 9 minus 5?
4. 10 to the power 4.
4. So we have 2. Okay, 1 minute. We have 2, 3, 3, and 10 minus. No, why minus 4? 4.
Not minus, only 4.
Yeah, only 4. So now, what is a 10? A 10. What is the factorial, the primer? So we have 2 and 5. Yeah.
Yeah.
Okay. It's correct, or
No. It's,
I think it's okay. No. Let me go back one step.
wait.
So you have 10 here. Yeah, it's correct like this. That's okay.
Yeah.
Oh, sorry.
Okay.
I said 4 here. 4. I think this is okay. Okay. So you have 2, 3, 2, 4, 5, 4, which is 2, 5, 3 in the power of 3, and 5 in the power of 4. Okay, so we made the extra, steps, which we shouldn't, because here we have like tens, some 10 here.
Yeah.
So we need to, be careful what they are asking for. Yeah, the last. Yeah, actually, it's okay that we are here because none of the previous steps have 5.4.
Exactly.
So what is a 5.4? 5.4 is like 54, you know? 54 divided by 2, how much? It's like a
It's gonna
game
be
already. How much?
20, is it 27?
27.
No.
Yeah. What is a 27?
27?
Yeah.
It's gonna be 3 to the power of 3.
3 multiplied by 9, yeah?
Yeah. Yeah. 3 to the power of 3.
Yeah,
Is it?
yeah, because we like 3 multiplied by 9, which is 3 in the power of 3. So, we already have, you know, so 54 is 2 multiplied by 3, yeah, correct?
Yeah.
So let's take it out from the what we reached to, like from here, okay?
Mm.
So 2 multiplied by 3 in the power of 3 multiply, I took it out, so what is inside still?
5 to the power of 4.
So I took 1 2, so I have 2 in the power of 4, correct?
Yeah.
Okay, I took all the 3 in the power of 3, I have inside only 5 in the power of 4, okay?
Mm. Yeah.
But we have just one problem, this is not 5.4, this is 54, okay? So what I need is I need to multiply this. I need to multiply this by 10 minus 1. So I need to multiply this by 10 in the power of 1. Okay, like this is 1. Yeah?
Yeah.
So if I multiply by 10 minus 1, this will be 5.4, all this. Yeah?
Yeah.
So what I have here, 2, 4, 5, 4, and 10. What is 10? It is 2 and 5, correct?
Yeah.
So that's, I think this is the final step. So it's 5.4. You have 2, 5, 5, 5, which is actually 10 in the power of 5. I'm not sure this was the most, you know, shortest way to solve it. We got there. I think from the beginning, if I would see this, yeah,
If we would see the 54 and just
yeah, for sure I will
divide it by
start.
10.
So, yeah, 54 from here, from the beginning, yeah, from here actually, yeah. You have, what we have here, 3, 3, 10, 6, what we have here, 2, and 10 minus 5. So, 54, yeah, I think it's much more easier to take it from here. I think it's just 2 steps actually. So 2, 3, 3, 10 minus 1, this is already 5.4, yeah?
Yeah.
And you have 10, 6, and 10 minus 4.
Minus 4?
Yeah,
Minus 1.
yeah, I took one here.
Yeah.
So this is 5.4, 10 the power of 2. Wait. You see, good that I didn't... let me check the answer. 60, D. No, this is correct. So what we made wrong here? It's not 6, it's 9. Sorry. 3, 3, it's 9. Yeah? So 9.
So if we did it as 9, yeah.
9 minus 4, it's 5. It's all okay.
Oh, so this is the easiest way. Why
Yeah.
did we go to...
You know, it's very important.
It's okay, it's good.
No, it's
good
okay to understand, yeah,
understand,
because as we spoke before, that we need also already to speak about fast ways, yeah. So actually, this question, and also I think this question also, you see, also here, we went too far, you know, also.
Yeah.
So in the school, always we solve. Here, you need to, you know, recognize the target, okay? The target is the answers. So yeah, you need to design the solution, I think, in taking in consideration
The
the
answers.
answers, yeah, not just
Yeah,
like
because
just let go, going to the maximum in one direction. Okay, so
yeah,
the strategy is not to go like in one direction, like fully. No, you need to connect the question with the
the
answers,
answers.
and then
Because it's 1 minute,
decide.
1 minute per question.
Yeah,
You don't have that much time.
yeah.
Yeah.
Okay, so this is question number 60. We finished this exam. Thank you very much. See you
Yeah.
next time.